Hello from Gdańsk. Tomasz Pawlowski here. I'm a Squish technical consultant with Froglogic. I would like to present you today how to create automated GUI tests for embedded applications. So currently, graphical user interfaces expose a lot of functionality. So as developers and testers, we need to make sure that the interface actually looks and behaves as intended. So in this talk, I will present a proven approach to creating fully automated, robust, and maintainable GUI tests for Qt applications running on embedded device. I will use an ARM IMX6 based device running Qt-based UI. And I will demonstrate how the Squish GUI Tester tool can be used to develop automated GUI tests. So at the beginning, I will show you just a few slides for maybe about 15 minutes. And later I will create a few test cases live. And next I will demonstrate the novel remote control. So how this new feature remote control from Squish works. We'll also discuss remote system functionality. This is also another new feature we have added recently. And both those features, remote control and remote system, both those capabilities are very useful for testing apps running on remote devices. And as usual, at the end, we'll have a Q&A session. So I will try to answer all your questions. In case of any doubts, I will forward them to my colleagues, and I'll try to find a way to answer those questions later. So the talk is planned for 40-45 minutes, and then plus Q&A. So a little about Froglogic, a Squish GUI Tester vendor. So Froglogic was established in 2003, and as of yesterday, it's owned by the Qt company. And our flagship products are Squish GUI Tester, which we'll talk a lot during this talk. There is also a Squish Test Center, which is a platform for test results management, and Squish Coco, which is a code coverage tool. And currently, Squish is used by more than 3,500 customers all over the world. Some of them are very well known, as you can see on the slide. We are very strong in the aviation, automotive, and medical industries. And many of these companies provide life safety solutions, and we are very proud that our products support them in their quality assurance process. So what, in fact, is a Squish GUI Tester? So it's a cross-platform multi-technology tool for GUI test automation. And Squish supports testing on the Windows, OS X, various Linux distributions, and other operating systems, including mobile, Android, and iOS. And Squish as a tool can be cross-compiled to other platforms, yes, like Linux running on ARM architecture. Yes, so this is the scenario I will demonstrate today. This is my setup. Tests that you create with Squish are fully portable. Yes, so they can be executed against different platforms and configurations without any changes. Squish features dedicated support for GUI test automation for all Qt widgets, QML, and Qt quick controls. You can even automate interactions with embedded web content if it's implemented using Qt WebKit or Qt Web Engine. And we support testing Qt Toolkit up to recently released Qt6. And we provide the support for new Qt versions as soon as they are released. And we also support custom controls, which are accessible based on the standard controls they are created, they inherit from. And with Squish, you have access to all the object properties, all the methods, and signals emitted by those widgets. Let me tell you a few words about Squish Architecture before we get started with a live demo. So the architecture is very important here because the Squish Architecture influence later on the setup that our testing setup to run our tests or to create our tests for embedded devices. So the Squish package itself contains various command line tools. So it is possible to run your tests in a distributed manner. So this is a typical setup for testing the application UI on an embedded device. So on the left side are the things that you run or on your laptop, on your workstation. So for example, you run there our tool Squish Runner, which is responsible for triggering test execution. It interprets your test scripts and it produces you the results. And there must be a communication between your laptop to a device. Yes, and on a device, you can run a Squish server, which is a process responsible for starting and handling application under test. However, for embedded testing, for testing the application running on the target device, we will not start the application itself. We will just attach to already running application. And of course, the Squish Runner and Squish servers and all the components, they talk with each other over TCP/IP protocol, and of course there is the internal Squish protocol that is used for this communication. But this is not only one possible setup. Yes, there are the second approach. Yes, the second setup is that you see we can move this Squish server to our workstation, for example, and we will run on the device that we want to test. We'll just run a tiny tool from Froglogic called Start IoT, which will be responsible for starting the application under test. And most of our users modify boot scripts. So whenever the process service it's started, it's started with our Start IoT tool. So kind of like a wrapper or program which starts other program. And thanks to that you start the application using our tool, Squish can interact with the application, Squish can verify the GUI elements. So all of that because we used this very small Start IoT tool. But there's also a third possibility of the setup. This is more like a fallback. So if the previous two are not working for some reason, the last way you can modify the source code of your application and install what we called built-in hook. And with this approach, whenever you just start your binary the regular way you start it, because the built-in hook is used, the small library that we provide, which is compiled with your application, then Squish can attach to the application and can control it and verify the UI state. So let's look at my demo setup. So I have my regular desktop, nothing fancy here, Windows 10, a regular Squish package, including Squish IDE, which I will use to design tests. On my desktop, I have a test suite, test cases, all the global scripts. I have a Squish runner, Squish server, and generated results will be there. My target device is ARM CPU IMX6 board. with just 1 GB of RAM, 8 GB of storage, and Squish is deployed to this device. And Squish takes only roughly 120 megabytes in this configuration. And device is connected to the network, so they can communicate with each other. I will show you my setup on my desk in a moment. Before that, let's discuss first how we can create test cases with Squish. And there are many ways. The first one, and many tools offers that, is just you can record your interaction with the application, and then Squish will generate your test script that you can later on run. This is the fastest way, I would say, but of course not the best. Then there is a manual scripting. Yes, so you can write each your test case programmatically, script everything. That's also possible. This is the way some more advanced users are working with. The most popular approach is a hybrid. So you do some recording and then you refactor your code, you do some scripting to have your test nice, modularized, and easy to reuse in a different situation. Going back to the recording, there is no need to always record your test, the entire test case. You can just record a smart part of it. So you can just record small snippets. If you want to extend an existing test case, there is no need to record the whole test case. Okay, so now I would like to do some more interactions with the application that I have running on the device. So give me a few seconds to point the camera not to me, but to a device. It's much more interesting than me. So now you will always see during my presentation, you will always see a device, and I will also share my screen when the Squish is running, when we will do the live coding. So you will see both. Okay, so if you want to design a test, you need to run the Squish IDE. Yes, and I have the IDE running here. This is the cross-platform Eclipse-based IDE. If you have ever worked with Eclipse, it's very similar. You have different perspectives here, which will automatically change when there is a need. And you use Squish IDE to develop, maintain, and debug your automated tests, or you can use also IDE to spy the UI components of your application under test. First, let me show you what I had to do to set up Squish to make it working. So if I go to the server settings, manage AUTs, attachable AUTs, and there is an entry called green box. And here you see the IP address and the port number. And this is the IP address of my machine, which I call green box because it's a green. And there is here you also see the port number. So this is the port number that we started application, and we gave this port number to the Squish tool at the moment we start the application, and hence I just need to configure it here. So I have a green box added to as my attachable application. Okay, so now I need to, if I want to design some tests, I need to create a new test suite. So I just gave it a name. So we have and I click next. I need to tell Squish what kind of application I will be testing. So this is a Qt application. So I just go with Qt, I click next, and then I need to decide what scripting language I'll be used to code my tests. And the tests can be recorded or scripted in a Python, JavaScript, Perl, Ruby, and Tcl. So all those powerful scripting languages are supported equally, so it's up to your team preferences which one to choose. Your test can be even more powerful when you extend scripting language by external modules. So we support those 5 scripting languages, but I can tell you that as of 2021, Python is the leader among all the scripting languages, and the second place go to JavaScript. Is based on my observations on the Squish users. So I'll go with Python. Now I will leave the no application, because I will attach to my application and my test suite is created. So now I need to create a new test case. So there are 2 types of test cases: scripted test cases or BDD type tests. BDD stands for business driven development, or business driven development and testing. I don't want to talk about BDD. It's a completely separate topic. We just use plain scripted test cases. We want to focus on different parts during this talk. So my test case is created, it's empty. So now I can hit the record button and we'll connect to my application running on the device. And now IDE disappeared. And as you can see, all the interactions with my application will be recorded. So let me just click on the tab here. I will click this button. And maybe I will click again to Advanced tab, and then to Buttons tab. And I click Stop Recording. And you can see that the test script is created. We'll walk through the code in a moment, but first let's just replay to see if that works. And you may be, Squish is kind of fast. So yeah, you see it was replayed very quickly. I don't know if you noticed anything, but those all interactions during the replay took just 2 seconds. We just have a green results here at the bottom, but we didn't verify anything. It's just some interactions with the application that is running there. So let's take a look at the code. Yes, so this is what you see is a Python code with Squish API. So at the beginning, I attached to the application, and after this line, after attaching, all those commands are performed on my device. And I can see we click on the tab, Qt widget, we go to buttons, we click on a button, and then we click on different tabs from the tab widget. We go to advanced, buttons, then, okay, just recorded a couple times that we go to buttons. Yes, this is just a Python code. Yeah, so I can easily copy one line and say, okay, now I want to go to graphs. Graphs tab, yes, and replay this test case. So now, when you look at the application, at the end, it ends on the graphs tab. Yeah, so the coding is really easy. Once you don't need to be a Python specialist. I would say that the basic intermediate knowledge about Python is really enough to create a good automated test. So how Squish works, how all of that is possible. So Squish hooks into the application, yes, and recognize the application GUI elements as objects. And with Squish, you can interact with properties and methods of those objects. So it's important and powerful that we are not relying on a screen resolution, screenshots of coordinates. So when a button you click in a test script changes its looks, location, your test script will continue working without any problems. So knowing that, let's go back to Squish IDE. So let's take a look at the line, let's say 9. Yeah, when we click on a button, we have there's a click button method, and then there is some kind of wait for objects. So you may notice this method returns to the object reference with some synchronization. And here is our object name. And how Squish knows where this button is, how to find this button. Yes, we are not using image recognition here. So I just click with the control on this name, and I move to our object repository, which is just a Python module. And here we have definition of our button that we clicked. And you can see Squish uses key object properties to recognize given object. Yes, so for the toggle switch button, we see this is the object located on this container with this type, Qt toggle switch, unnamed, visible. And this is the way it works for every object you interact with. And this can be easily modified, customized to your needs. Okay, so we didn't verify anything yet. We just click on different tabs. Let's move on and create our first test. So I will create a new test case in my Squish IDE. I hit a record button again. Okay, green box application, the same one. Let's look at the device. I will go to buttons. I will click on the toggle switch. And now you can see that I would like to verify that this light is on. Yes. So how we can do this? We look at the control bar. There we can add verification, and the verification points can be used to verify the expected results of a given test scenario. And with Squish, you can verify, as you can see, object properties. You can verify, do screenshot comparison. You can verify table content. You can do visual verification of a content, geometry, topology, visual appearance. Recently, we have added more verification types like search image verification, which is purely image-based. And there's also OCR verification, where you can verify the given text is displayed on the screen using OCR technology. Okay, but we'll verify object properties. So I want to verify object property. I need to tell Squish, okay, which object you want to verify. And I will use this picker tool. I want to pick my object. And if you look, I will just go to the application. I will just tap my object, SVG LED. This is the object I want to verify. And we see on the Squish ID, the picked object, bottom right, we see all the object properties and current values. And I would like to verify glows property. I know this property is true because currently this LED is on. So I add the glows property. I can add more properties here, more objects. I'm done with my simple test case. I'm back to the recording, and I click stop recording. This is my test case. Okay. I would turn off this light because my test case would fail. And you can see at my test, yes, I click on the tab buttons. I click the toggle switch. This time I will extend my test case to add some logging. Switch. And then we verify that the light is on. Let's extend this verification. The last line, the test comparison, the glow property of this object should be true. And we'll add some comment, LED should be on. Okay. Let's run our test case. We'll see if that passes or fails. Now the test case passes. We have better test results. We click on the switch, and then we have our test comparison. But look at our device. If you run this test case again, it should fail because after clicking on the switch button, we'll turn off this light. Yes. So before I run the test case, and we expect now the test case to fail, I will go to test switch settings, test settings, and I will enable option log screenshot on fail result. Okay, let's run our test case. This is what we expected. Yes, we click on this light again and we turn off the light, so our test case failed. How to make it always passing? It's very easy. We can make some coding saying that only if the light is off, turn it on. So we can say if the light is not glowing, yes, so light is not on, so just if not, and then we run this command. So with a simple Python coding, we can add some logic to our tests. run the test case again. You can see it turned on the light, the test case is passed, and now basically nothing happened, will not turn on the light because it's already on. So this is the simple but also the most common use case for verifying that the GUI is as expected. You just verify some properties, but maybe there is a need to verify appearance of your application, of some controls. So let's look at the device again. Look at the speed gauge. I can set a speed using this slider, and this speed is shown on the speed gauge. Of course, I could verify value property of the speed gauge, but I would like to this time verify that the speed gauge looks as expected. So let's add some verification point. So I click the record button. And now I use this slider. I set some value, and now I will go to verify a screenshot. I will pick my speed gauge, click a checkbox here to make a screenshot. You see now the expected look is there, and I click Save and Insert Verifications. And let's go with a stop recording. So this is my test case, yes? So now just set a speed to 42, and I expect my speed gauge to look like this. This is my expected result, yes? So let's run it to see if this passes. Awesome. We have a pass verification, screenshot comparison of electric car speed SVG dial gauge passed. Yes, images are identical, expected and actual. But let me, in my test case, set a speed not to 42, but to 55, and run my test case again. I will not change the expected image, so now my test case should fail. And exactly that happened. So now Squish is telling that the actual and the expected images are different, and we can take a look, okay, what is the difference between them? We open from the IDE, we can analyze the difference between expected and actual image with different modes. We can analyze the difference. We can modify, we can apply mask, we can work on the different comparison mode. There's plenty of options. I will not discuss them during this short talk. We can also say that my image is as expected, and you can accept this image just from the context menu, and it will be new expected ones. Let's move forward, and let's implement test case number 4. Not a test case, but I told you there is no need to record always the test case from top to bottom. You can always extend an existing test case. Yeah. So I have here some different sounds. Okay. Yeah, I will continue. So I just would like to extend my test. Yes. So let's go back to the test case number 2, and let's say I would like to, at the end, I would like to click on the toggle switch button. I can just add a return statement, put a breakpoint here in my test case, replay the test case, and the test will be continued till the breakpoint is reached. You can look at the device. This is the way the device looks at the breakpoint. We have full debugging options to analyze the application objects, current properties. So full debugging possibilities here. One of the options, I can record a snippet. I'll just turn off, click this button, click stop recording, and I can terminate my application. And you can see that the new code was added just above the breakpoint. So everything, so it's of course possible to extend the test cases in such a way. So let me show my presentation again and move to some more advanced features that you can use to test your UIs. And let's take a look at the visual verification. So conceptually, visual verification is a hybrid form of property and screenshot verification. So both types of checks, using property verification, using screenshot verification, this is the hybrid, this is a combo. And they're combined into one algorithm to find the best possible match. So unlike the screenshot verification, they do not treat the rendered screen content as single surface. Yes, the area of your verification is divided and compared per individual UI control. So rendered pixels, position, size, and content properties are compared against expected value. So when to use this visual verification? This looks like a big weapon, but of course you need to know when to use it. If you can use that to check on-screen display of dialogues, whole application windows or subsections, not the entire, not a single control. Of course, by default, the Squish is very strict when comparing images. When doing visual check, everything can be relaxed, so your tests are more robust. So let me go back to the Squish IDE and create a visual verification. I'm again recording. I'm just now interact with my device. I will go to gauges. I will set some speed, some heating value. I would like to verify all those three indicators on my device. Yes, so I go with verify visual. Workflow is the same. Let me pick the object. So I just touch the screen and I pick the Q group box, which is perfect. I'll click a checkbox. Now Squish fetch all the information about this Q group box and also all the objects located on this Q group box. Yes, and I click save and insert verifications. I'm back to the recording. I'm done. Okay, let's look how our test case is really a small one. Yes, we go to the tab. We set a speed, we set a heating, and we expect our verification. We expect the visual appearance of the Q group box to be like this. It's not just image. If I click on the pencil button here, zoom to fit, you can see what is verified there. Yes, on my Q group box, there are different objects. Q labels, Q sliders, the speed gauges, all of them will be compared. For all of them, we'll do different phases of checks. Verify the content, some properties, everything is customized here, customizable. We verify the geometry and topology, so sizes and locations of each of the controls. And finally, we verify, for each of the control, we verify that it looks as expected. So in one line, a lot of checks. Let's run our test case to see if the test case is pass or fail. It passed. We didn't change the test case, but let's set a speed to 22 in our test case. And now we should observe that after changing that on a device, our Q group box should look differently. So we are now seeing that there was a failure in our test case. And if I go with view differences to analyze what is the problem, what is the difference between actual and expected, I actually see that there are a lot of failures inside on my Q group box. That here on the top left, I see which objects are different now. So if I click on this speed gauge, I can also click it here. On the right hand side, for this one, I can see that there is a content verification failed, so properties failed, geometry is passed, and the screenshot is different. Yes. For the slider as well, And you may notice also this indicator is different also on the content level and on the screenshot level. This indicator failed our verification. So this is really a combo of different checks, and you can verify many aspects of your application of the UI, both appearance and content, in just single line of the code. So so Squish works mostly on the object-based recognition. So for the image-based testing is best used for applications with the custom controls. Yes. So whenever you cannot use object-based approach, you can use the image-based approach. If your application is built with unsupported toolkit, or for which object properties are not available to Squish, you can also use image-based testing to test 2D, 3D graphics and plots, such as medical imaging data. And with image-based recognition, UI control is recognized by its appearance, and the Squish user can design a scenario to verify the image presence or to perform action on the image. Yes, so we forget about interaction with the objects that we recognize in our test cases, and now we will verify the images. So yeah. I will skip this demonstration because we are a bit behind the schedule, and I will move to the next topic, which is I wanted to show you, which is a remote control. So with the remote control, it's really one of the challenge when you have when you test the application running on the device is what to do if a target device is not in the same physical location, how to record a test case on such a device, or pick object using picker tool. Yes, so the solution is the remote control feature. And so when working with the remote application under test, Squish allows you to stream the display of the remote device locally to your machine in the real time. So when interactively recording tests, you can interact with the remote viewer, not with the real device, to pick the objects for the inspection. You can use the Squish spy tool for setting up a verification point. You can preview the current state of the application during a debug session and more. So there is no need to install any additional software. Everything is embedded within the regular Squish communication, so there is no need for additional setup. So let me create a new test case, and I will click the remote device record button. I will connect to the green box. See, and now I will click the remote control. Now on my desktop, I see everything. You can compare that. You see also a device. When I will click something on a device, I will go to buttons. My preview window in the application changes as well. Whatsoever, I can also click here on the sliders, for example, and I will move, and also I interact with the device itself. So this really solves the problem of needing to have then access to a device. So, and if I click stop recording, you can see that all my interactions were recorded. That I didn't interact with the device. I just interacted with my preview window from the Squish IDE, and which is still open after finishing recording, and this way the physical access to a device is not needed. So everything I show you before is also true for the using remote control as well. Finally, I would like to tell a few words about a remote system. I'm not able to demonstrate to that because a remote system is used to, this is the object inside of your Python script that you can use to for operations, file system operations, process execution on the system where Squish server is running. So in some case, the system that your AUT runs is not the same as the Squish server runs. That's the way, this is my setup today. That's the way I wasn't able to demonstrate that. But if I also run Squish server on a device, from my test script, I can open a file which is on a device. I can start or stop any process on a device. I can upload, download files between local and remote system. I can obtain information about the remote system. So there is a plenty of ways for the interaction. It's because let's say you have a test case where you need to verify that your application creates a file on the system. Yes, if you run your test case on a desktop, of course the Python script is run there. The file is not there. Yes, the file is on the device. Yes, but with this remote system, you can basically download file or you can upload a file and do such verification. So I would say those two functionalities, remote system to perform different operations and the remote control that I demonstrated before, are the ones that we implemented really recently and that really push our possibilities for testing embedded on the target devices to solve all the challenges that our current users had. So this was the answer for their challenges. So if you need to get more information about Squish, about Froglogic, you can go to froglogic.com and we have a vast documentation there. We run our blog when we post tips, different tips weekly. You can also try fill the request form and get an evaluation version of Squish at any time. Yeah. So thanks a lot. And now, if you have any questions, I will be happy to answer them.
Thank you, Tomasz. Now I have my mic on. We have a few questions here for you. The first one is, you mentioned that Squish uses 120 megabyte on the embedded device. Is that 120 megabytes of RAM or storage?
That's a storage. So basically the regular Squish package, when you download that, it takes 700, 800 megabytes. Yes, but the Squish package on the device is actually cross-compiled for a specific device, and therefore it's very small. Yes, it doesn't contain IDE parts, it doesn't contain any documentation, and it's really stripped down only to run on the device. That also means I have a regular Squish package on my desktop, which is a full Squish package, and on device I just have a 120 megabyte of storage Squish package.
Gotcha. Next question. If the UI is updated, how will the generated names get updated? Do you need to record them again?
Yeah, there is no need to record the names again. So this is just a text file, yes, names.py, and during the update of the UI, you can just modify this file. Yes, but basically. Squish uses not only key object properties, yes, to recognize given controls. So only if this key property changed, then there is a need for modification here inside this file. There's no need to record anything.
Okay. Where do the names come from? Is the names .py written automatically?
Yes. Whenever you do recording, whenever you record with any of the control or you verify any of the control, the proper entry is added to this object map, to this names.py. And this file can be shared among all test cases, all test suite. It can be a global one. So there is no need to have a duplicate entries among multiple test cases.
Okay. Last question. Would you recommend integrating these tests with a iterative lifestyle? Will this be a lot of work to re-record and rewrite the tests over time?
I'm not sure I get the beginning of the question. Could you...
I'm not sure. I don't have direct contact with the person who asked this. So maybe we'll just take the second half. Have people found that it's a lot of work to re-record and rewrite tests over time? And other tips you could give us maybe to minimize the amount of work it takes to maintain these?
Yeah, so basically, creating your automated tests is like a software development project, yes? And when you design your software, you don't want to have a lot of duplications in the code in case of there is a need for change. The same is with the tests. So we always advise our users to create a test framework, to modularize your tests, to create a global scripts where you create your own functions to interact with the application. Yes, and then from each test case you call just a function. So you must assume that your application will change. Otherwise, there is no need for testing. Yes, if your application doesn't change, so you need to design your test that whenever there is a change, it's easy to adopt your tests. There will always be need to adopt your tests. Yes, the question is how easy and how much work is that. And so if you modularize your test framework, if you put and do it in a smart way, you just need to, when there is a change, you just modify your test base in one place and the tests are working again.
Gotcha. We had one more come in here. Can you tell us about the license? Is there open source? Is there a free version?
Yeah, there's no free or community version. The licensing model is that we have this a commercial tool comes with a commercial grade support. So whenever you run into any problem, you contact with us, and we try to help you to overcome this problem. So and the licensing model is at this moment we offer a floating license where you install a license server, and then this server is in use. So everything is, if you go to the froglogic.com, the licensing model and everything is explained there.